Welcome to experiment number 7 in Digital Electronics 2 Lab, and for this session, we will be using the Pulse Width Modulation built-in in our 8-bit PIC microcontroller. The objectives of this experiment are, number 1, to understand the pulse width modulation or PWM operation, and number 2, to apply PWM in brightness control of the LED. Pulse width modulation or PWM can be useful in many ways. 1. Being able to control the brightness of an LED. Varying the time between the pulses at a very high rate can make the LED look dimmer or brighter without the human eye detecting the flashing. The same technique can be used for speed control of motors. So PWM can also be a useful technique on many designs, and a PWM peripheral is built into most 8-bit MCU devices or microcontroller devices. In the experiment, we will use the MPLAB code configurator or MCC to generate a code to control the brightness of an LED. So using the hardware PWM peripheral, we will be able to generate the variable on and off time at a very high rate. So this on and off frequency averages out to appear a variable brightness on the LED. Now let's go to MPLAB IDE. Let's go to File, New Project, Standalone Project. We will use PIC 16F18875. Choose XC8 Compiler, and let's name this EXP7. After that, let's click MCC or the configurator. Now let's just save this my config file. Here in the Pin Manager grid view, let's change our package to PDIP40. Here in the project resources, we will add the PWM module and the timer 0 module. We can locate it here in the device resources. Now let's go to PWM and select PWM6, add, and for the timer, let's add timer 2. Here in the timer 2 setup, enable timer. Then for our timer clock, clock source. From high frequency oscillator, we will set it to frequency oscillator over 4. For our prescaler, the ratio is 1 to 1, and for our postscaler, our ratio is 1 to 16. For the timer period, we will set it to a maximum value of 16.384 milliseconds. After that, let's set up the PWM6. Here, enable PWM and select our timer to timer 2. Check if the duty cycle is 50% and our PWM polarity is active high. After that, let's go to Pin Manager. Then the LED will be assigned to PWM6 output here at RA4 or port A4. After that, let's go to System Module. To oscillator select, High Frequency Oscillator. High Frequency Eternal Clock 4 MHz, Clock Divider 4, and enable Low Voltage Programming. Here in the Pin Module, make sure that Analog and WPU is unchecked. Then let's click Generate. Generation complete, let's go to Projects. Source file, load our main C file, and load PWM6.c. Now let's make the code. We will look for PWM6 underscore initialize here in the PWM6.c. There, copy that. Then let's create the code. Then we will also call PWM6 underscore load duty value. It is also located in PWM6.c. And continue creating the code. To explain this code, first, we initialize the PWM6 function of the PIC microcontroller. Then we input two integer variables, duty and delay. And we also use two for loops. So in the first for loop, we set the duty variable to a value of 1, then duty is less than 512, and duty is equal to duty plus 10. To explain that, when the program starts, initially the duty variable is equal to 1, then duty is equal to 1 plus 10, and that is equal to 11, which is less than 512. So the program will repeat and stops when the duty value is no longer less than 512. After that, we call the duty variable using the PW6 underscore load duty value. And for the second for loop, we also set the delay variable to a value of 1. Then delay is less than 500 and delay plus plus. The program also repeats until the value of the delay variable is no longer less than 500. Now let's click Build. Build successful. Now let's connect our PK3 and MICROCHIP to our computer. Now let's connect our PK3 to our computer. Here in the PK3 adapter, first pin M control, second pin VCC or VDD, third pin VSS or ground, fourth pin ICSP data, fifth pin ICSP clock. Now let's connect it. And connect our microchip. Here in MPLAB IDE, let's go to power. Voltage level should be set to 3.125. Power target circuit from PK3 should be checked and operate, connect. Then load our hex file, browse. Load our hex file. Hex file loaded successfully, then click Program. Programming complete. Now let's create the circuit. Now let's put a connecting wire to the PWM6 output in RA4 or the 6 pin. Then connect it to the positive terminal of LED. The negative terminal of the LED is connected to the resistor, and the other end of the resistor is connected to the ground. VDD 11 slot, positive 5 volt supply. 32nd slot VDD, also positive supply. 12 slot VSS, ground. 34 slot VSS, also ground. Connect the positive supply and negative supply. Now let's test the circuit. With the code that we use in the MPLAB IDE and utilizing the PWM built-in feature in Quick Microcontroller, we were able to control the brightness of the LED in a span of time. We can also observe that the LED operates based on the variable input of the PWM. Now let's try to modify the code wherein it will take a longer time for the LED to light up. Let's modify the duty equation. Let's change this number 10 to 2. Then click build. Build successful. Load again the hex file. Connect again our microchip via PQ3. Then click program. Programming complete. Now let's test the circuit. So as you can see here, we modified the duty equation to duty is equal to duty plus 2. With the modification, it takes a longer time for the duty value to reach a value of 512, which also makes the LED to reach its maximum brightness for a longer period of time. Now let's modify again the code wherein the LED will reach its maximum brightness at a faster rate. Let's change the value of 2 to 75, then click build. Build successful. Load again our hex file. Load again our microchip to our computer, then click program. Programming complete. Now let's test the circuit. As you can see here, we modified the duty equation with a higher increment of 75. With that, the delay value of 1 will also reach a value of 512 at a faster rate, which also makes the LED output to reach its maximum brightness at a faster rate. There. So with the use of the Pulse Width Modulation built-in feature in our Quick Microcontroller and the code configurator and MPLAB IDE, we were able to control the brightness of an LED.